Lesson 5.5, solving absolute value inequalities with a greater than symbol or greater than or equal to symbol. Our essential question, what are the two types of graphs that may represent a greater than or equal to absolute value inequality? So there are two types of graphs again. You may recall that when we worked with our less than or equal to absolute values, that the two types of graphs that we saw were an interval or an empty set, because those were intersections. They were intersections. So today, we should be looking for unions. So, my number line question again. You're standing on a number line. This time, I want you to describe all of the points that are greater than 2 units away from you. Greater than 2 units away. What type of a graph is created if you graph these points? Well, 2 units away would be right here or right here. But this problem says it's greater than 2 units away. So I am not going to have an interval like I did before. I am instead going to have 2 rays that are pointing in opposite directions, because it's not 2 units away, but it has to be greater than 2 units away. So more than 2 units away from me on that number line, there are going to be an infinite amount of points that are more than 2 units away. So if 2 rays are created, that means that we are talking about a union of 2 events, and our keyword is OR for our compound inequalities. Now, how about a negative number? What if you are greater than negative 3 units away from the person on the number line? What kind of numbers are greater than negative 3? Well, greater than negative 3, you would have a lot of numbers. A lot of numbers are greater than negative 3, like negative 2, negative 1, 0, 1, 2, 3, 4, and so on. Because we're talking about distances, can you be greater than negative 3 units away from something? Well, you can't be negative 3 units away. You can't be negative 2 units away. And you can't be negative 1 units away. You could be 0 units away from something if you're right exactly in the same spot as that other object, I guess. But you could also be 1, 2, 3, 4, 5, and so on units away. So look what happens if we graph that. 1 unit away, 2, 3, 4, 5, and so on. It's just going to keep going. Same thing in the other direction. 1, 2, 3, 4, 5, and so on. So greater than negative 3 units away from that person would be all real numbers. It would be the entire number line. Every single spot is going to be included when you're talking about greater than negative 3 units away. So the second type of graph that you're going to see is going to be all real numbers. So 2 of the 3 that we learned when we worked with our compound inequalities with the word OR, we had all real numbers, we had 2 rays in opposite directions, and then we had 1 ray in the same direction. That's the only one that you're not going to see today. All right, solve and graph, case 1 or case 2. Okay, if I solve case 1 by adding 8, I get x is greater than or equal to 10. If I solve case 2, I am going to put a negative 1 in front of my parentheses. Remember why we have case 1 and case 2. This absolute value, it could be greater than or equal to 2. It's a distance, okay? The opposite of x minus 8 has the same absolute value. It has the same absolute value. So that's why we have to solve both cases, because x minus 8 has a specific absolute value, and so does the opposite of it. They have the same absolute value. Kind of like the absolute value of 2 is 2, and the absolute value of negative 2 is also 2. 2 and its opposite have the same absolute value. So x minus 8 and its opposite have the same absolute value. So anyway, over here in case 2, I'm going to divide both sides by my -1 because I like to think of my two inequalities as x minus 8 is greater than or equal to 2 and x minus 8 is less than or equal to -2. So I like them to look alike, So case 2, I think of flipping the symbol and changing the sign. Flip and change to get my second inequality. Now if I add 8 for my action step, I get 6. So x is less than or equal to 6 or greater than or equal to 10. We will graph them separately and then we will put them together as a union, just like we did in the last section. So 6 to 10 on each of my number lines. My red one is greater than or equal to 10. My blue one, less than or equal to 6. And if I unite them together, look what happens. I've got 2 rays. 2 rays. Okay? So, move this one back down. And my solution is going to have both of these rays on it because a union, or the word or, says that it only has to be on one or the other. It does not have to be on both of them at the same time. That was an intersection. So when our absolute value inequality has a greater than or equal to symbol, it is going to be an or compound inequality. An or. Next example. This one is 2 rays again. The equations are just 2 steps. So x is greater than 4 for the first one. For the second one, remember I'm going to flip and change it. Flip and change. That's just dividing both sides by this -1 that's in front. Now my action steps are exactly the same on both of my inequalities. So x is less than 1. Now if I graph them, my graph just needs to go from 1 to 4. The red one, open on 4, greater than goes to the right. Green one, open on 1, less than goes to the left. So if I unite them together, I am simply going to have 2 rays again. So here is my solution. And I can put the word or in between up here. There is our answer. X is greater than 4 or x is less than 1. Type 2, where it ends up being all real numbers. I can show you why that happens. So this is very similar to our last section, 5-4. Case 1, x is greater than or equal to 2. Case 2, where I flip and change. So flipping the symbol means it's now a less than or equal to. Changing the sign means it's now a positive. So if I add 7, I will get x is less than or equal to 12. So my graph is going to have to go from 2 to 12. Okay, the red ray starts with a closed circle on 2, and it goes to the right, greater than or equal to. The green ray would start on 12, and it's less than or equal to. So, with my connecting word or, if I unite together these two graphs, what you should see is that it covers the entire number line. Every single number is included, so our solution is all real numbers. If you wanted to graph that on your number line, you could graph the entire thing in both directions like this. So that's the second type for absolute value inequalities with greater than or equal to symbol. You are now able to write your summary and your homework problems. Page 312 to 313, number 4 through 6, 14 to 19,